Hey, this is Aval, and today we'll be talking about face recognition using TensorFlow. Now, our main objective here is to try and explain an attempt at facial recognition using the machine learning open source library by Google, that is TensorFlow. What we use here is a simple stacked convolution neural network, which will be trained on a set of images, validated and tested to see if two images differentiate based on which image has which person in it. We'll talk about our data set in a few minutes. Um, my motivation basically started with computer vision. Computer vision is a huge field where we use the sensors to try and get data, and then we work on that data to identify what the sensor is seeing. Or based on what the data is, we make certain actions and do make our applications based on it. So I basically started using OpenCV and MATLAB in order to do computer vision in previously. So I was really interested to take a dab at facial recognition when the machine learning was introduced, because it changed the things in computer vision drastically. Now, machine learning is basically just trying to replicate how your brain works. Just see how would your brain work. So in order to learn something, what happens is your neurons they basically change depending on what you are trying to learn. Similar way, uh, our neural network has neurons, and whenever you train that network, what happens is um, there are weights on neurons which are changed and modified depending on what you are training the system on. So um, in the computer vision field, it gave us a huge advancement because we got the convolution neural networks introduced, which basically use filters in order to train the system. And the other factor was that we had huge amount of data in the vision field, um, which was open source and could be utilized to learn and to understand machine learning in computer vision to a next level. Now, there was these big tech giants that actually stole the game from everyone because they have access to huge amounts of data that no open source data set has. Um, so um, every big tech giant was working on machine learning algorithms for computer vision, just like object detection, object recognition. And you can see the Google just recently came up with the object recognition API to in order for people to use. But having that kind of access to the data always helps us in machine learning, because more data you have in machine learning, the better your um, network can be trained on that. So we will be talking about some related work. Now, these are not basically face recognition networks or projects, but these are more into the visual recognition. So basically, any image, object recognition, object detection, stuff like that. So these are a few examples. What how these started to come in play mostly is with the ImageNet large-scale visual recognition competition. So they this competition provided a large ImageNet set, um, And this data set had um, a, around 11 million images um, to be to train the system on. And this competition allowed anyone to participate in it and try and give top 5 error rate that is less than previously seen, or the best possible top 5 error rate. Now, the game basically changed when AlexNet came into the picture, because the AlexNet changed the top 5 error rate from 26.2% to 15.4%. Now, this was a huge advancement when convolution neural networks came into play with along with the ImageNet dataset. Now, after that, the ZFNet was introduced with an 11.2% top 5 error rate. Then VGG got it down to 7.3%, and GoogleNet got it down to 6.7%. And then finally, there was a ResNet, which which came to a top 5 error rate of 3.6%. Now, um, I know there have been many more advancements to these algorithms and these convolution networks, um, but when we want to just take a step back and look at the top 5 error rate of ResNet. So the top 5 error rate of ResNet is 3.6. Now, according to Andrej Karpathy, you can see in my acknowledgements there, um, the average human sees about 5 to 10% top 5 error percentage. So we have been able to get a comparable vision application to the human brain. Um, so the machine learning has actually fascinated the computer vision industry um, by giving us solutions to problems which never really existed before. Um, and Now we'll just talk about our project, our data set. We used LFW data set. We used a subset of the set, and we took two people, uh, George W. Bush and Colin Powell's images from the LFW set, and we trained our system a simple stacked convolution network with 5 convolution layers in it. We trained the system on a training set, a validation set, and a test set. Now, the training set, the validation set, and the test set were all separate. There was no correlation between the training set and validation set and test set. The images were randomly um, parted into these 3 sets, and the test set was never used while training the system. The test set was only used to test the convolution neural network. The training set was used to train, and validation set was obviously used to validate the system. Um, Now we'll just talk about our architecture. What we did here was we used convolution layer, and then we used a max pooling layer, and then we used a convolution layer. And this is basically a derivative of actually, we started off by learning closely on the VGG architecture, and then we started from scratch and created our own network to try and differentiate between the images. Now, what we did here is that we started off with 64 filters in the convolution neural network, convolution layer 1, and then we did a max pooling, and then we did a convolution layer 2 which was 128 filters, and then 256 filters, and then 256 filters, and then 512 filters, and then 512 filters again for the convolution neural networks. Now, the max pooling layer, what it does, it takes the number of pixels that we have, and it just tones it down and brings us less amount of data that is more relevant. Now we use the stride of 2 for the max pooling layers, and for the optimization we use the dropout. So what happens is in dropout is when we get the features out of the other layers, we have some relevant data and we have some irrelevant data. Dropout basically gets rid of the irrelevant data and uses the relevant data. We use the dense layers to basically use the weights and try and give weight to the features that matter more than the others. So when we trained on this architecture, we tested on a specific random image from a set, and we were able to identify it as Colin Powell. We ran it on our whole set, and we got an efficiency of around 91 to 92% on average. And this was on both test sets. Um, so we were able to achieve a pretty good efficiency based on a simple architecture of convolution neural networks. And we used 5 convolution layers for the same. And I really want to give a shout out to my professor and the Google AI resources and everyone with their papers giving helpful information to us. Thank you, everyone.